Okay, now we've seen that the sequence 2, 5, 10, 17, 26, 37 can be generated by adding 3 to the first number, then adding 5, then adding 7, then adding 9, then adding 11. The same is true of the sequence of squares, 1, 4, 9, 16, 25, 36. The same is true because the squares are all just one less than the numbers here. So the differences between the numbers, the spaces between the numbers, are going to be the same. If you decrease each of these numbers by 1, you're going to get what? 1, 4, 9, 16, 25, 36, and it shouldn't be surprising that you get the same numbers when you subtract these as you got here. Okay, well then I represented 4 square lattices. Of course, the first lattice you can't tell is a square because it's only one dot. Could be anything, but when you get to the second pattern, you see I put those into a square, and then these into a square, and these into a square. Okay? Now, when I created this square, I can think of this square as having been created by first writing down this one, which is of course just your dot, and then extending the pattern 1 dot in this direction, 1 dot in this direction, and filling in whatever needs to be filled in. So that I repeated the previous pattern, and then I extended things, and in extending I had to add these. Okay? Then I'm going to repeat the pattern I had previously. The pattern I had previous to this one was the square with 2 rows of 2. And what did I have to add? Well, I had to add these. Then I can repeat the 3 by 3 square. And I'll circle it. Kind of a flat circle, that's what I need. Okay, so this is the same as this whole pattern, and now I've added all of these. Okay, now how many do I have? Well, I start with, how many dots do I have? I start with 1. Then what? Well, here I have 1 dot from before, but then I add 3 more. And of course that equals 4. And now what do I have? Well, here I've got 4 dots. I got to add how many? 1, 2, 3, 4, 5. And that gives me 9. Okay. And now I've got how many? I've got 9 here. And I'm adding 7 more, I can count them, and I get 16. Okay, now the numbers that I get are what I get. The numbers in orange are just the numbers that I got in the previous step. I add 3 because, well, I can count. Okay, I add 3. Now, on the next step where I've got to extend each, well, let's say extend 1 unit in this direction, 1 unit in this direction, fill everything else in. What am I adding? Well, I'm adding what I'd added before, the 3 here, that's here, and then I've added 2 more. So I always have to add 2 more than I added before. Here I added 3, here I'm going to have to add 5, here I'm going to have to add 7, and so forth. And every time I take the pattern 1 unit more, obviously I'm going to have to add 1 more along the top, and I'm going to have to add 1 more along the side here, which means, okay, I've added 7 here. In the next step I'm going to have to add 7 plus the 1 here and the 1 new one here, or 9, and so on. So that I've established a pattern, a geometric pattern, And that geometric pattern is identical to the pattern I get here. Now the geometric pattern has explanations, but this one doesn't. Okay? But you see that, well, I want to really talk about the pattern here, not here. The pattern here is I've got 1, I add 3, I get 4, I add 5, I get 9. Well, I've got 1. I take that 1, I add 3, and I get my 4. I take that 4 and I add 5 and I get my 9. Okay? Just like I add the 5 to get 9 and so forth. So this picture is easily correlated with this pattern, and this picture actually explains this pattern. Because, of course, the squares of numbers are just represented by the number of dots in these lattices. Okay, so what you're seeing is that we have something here that's explained by something over here that doesn't look anything like this. And in the process of problem solving, the field is completely open. You've got a problem to solve, you can pull in any information, any ideas you have from anywhere else. You pull in this idea from geometry, and the simple geometry of a square, the representation of a square number by a square lattice. And you get an explanation for something that might be more difficult to explain in some other way, like algebraically. You can explain it by algebra too, but I don't want to put a lot of algebra on you because the algebra prerequisite for this course is not that stringent. Okay, so now that's what I also explained down here with the same pictures. But if I'd have just pointed to the pictures, you wouldn't have seen it in the way I hope you saw it when I actually drew the thing step by step.